Energy is the single most powerful idea in physics because it is never created or destroyed, only moved around and changed in form. Follow the energy, and you can solve problems that would be a nightmare with forces alone. This unit is the accountancy of energy, how it is transferred, where it is stored, and how fast it moves. This unit builds in four moves: work, the way a force transfers energy; the two great stars, kinetic and potential; the principle of conservation that ties them together; and power, the rate at which energy is transferred. Let's start with what work really means in physics. Work in physics has a precise meaning. Work is done when a force moves its point of application. Work equals force times the distance moved in the direction of the force. Push a box across a floor and you do work. Hold it still, and however tired you feel, you do zero physical work because nothing moves. The angle matters. If the force and the motion line up, full work is done. If the force is at an angle, only the component along the motion counts, hence the cosine. And if the force is perpendicular to the motion, like the tension holding a ball in a circle, it does no work at all. Same force, but no energy transferred. Energy hides in two main stars in this unit. Kinetic energy is the energy of motion, 1/2 mv squared. Notice the v is squared, so doubling the speed quadruples the energy, which is exactly why crashes get so much worse at higher speed. Gravitational potential energy is the energy of height, mgh, the work done lifting something up. These two trade back and forth constantly. A falling object loses height, so its potential energy drops, while it speeds up, so its kinetic energy rises. A pendulum swinging is pure potential at the top of its swing and pure kinetic at the bottom, endlessly converting one into the other. The total stays the same. The big idea: energy is conserved. The total energy of a closed system never changes. So for a falling object with no air resistance, the kinetic energy gained exactly equals the potential energy lost. Set them equal, and you can find a landing speed without ever touching a force or a time. Energy makes the hard problem easy. In the real world, some energy always leaks away, usually as heat from friction or drag. It is not destroyed, just spread out into less useful forms. That is why a bouncing ball never returns to its original height. Each bounce transfers a little energy to heat and sound. The books still balance, the energy just went somewhere less convenient. Power is the rate of doing work, energy transferred per second, measured in watts. Two cranes can lift the same load to the same height, doing the same work, but the more powerful one does it faster. A handy second form is power equals force times velocity, which is why a car needs more power to hold a high speed against drag. No real machine is perfect, so we measure efficiency. The useful energy output divided by the total energy input as a percentage. The rest is wasted, almost always as heat. A good electric motor might be 90% efficient, an old filament bulb barely 5, dumping the rest as heat instead of light. Efficiency can approach 100% but never reach it. Here is the whole unit as one poster. Work is force times distance moved in the direction of the force, with a cosine for any angle, and no movement means no work. Energy lives in two main stars: kinetic, 1/2 mv squared, and gravitational potential, mgh. Energy is conserved. For a fall with no resistance, kinetic gained equals potential lost. Power is the rate of energy transfer, W over T, or force times velocity. And efficiency is useful output over total input, always below 100%. And the boundary fence, so you do not over-revise. The energy stored in stretched and compressed materials is the deformation unit. The energy carried by waves comes later. And the deep thermal physics of heat and internal energy waits for it too. Here it is work, the two stars, conservation, and power.